if you look at the first two homework, the first one, you got 23 students who submitted homework assignments. Homework two, there was 18. So now if you submit homework two, I would take away 10%. And then homework three, there are only like 11 students who submit the homework. So I really need to get it done by tonight and hopefully tomorrow night because the homework grades are very important to us. Okay, so we know something. And so remember that homework three worth 20 points, which is double from homework one and two. So I hope that you guys gonna submit it hopefully by tonight. If you kind make it by tonight, try to submit it in the morning tomorrow. So that would be great. And remember that the homework is a very important part of your grade. If you don't have it, like you're gonna lose 30%. So I just want to make sure that you guys have your homework submitted. And so now we're gonna do the exam review, like I said. There are 13 questions going to be on the test. Exam one, 13 questions on Wednesday, 25th. Okay. All right. So let me just go over some topics and let me know if you have any questions, any concern. Very likely that we'll let you out early because, like I said, that we have a snowstorm, and hopefully we're gonna get the snow clear tomorrow. So let me just take a look at the exam review questions. So make sure you're gonna bring like the calculators and the page of notes. And so that's very important. I really want to make sure that you guys know exactly what you do. Sorry about that. All right. So for the first question that you might have on the exam, so you need to find a domain of a certain function. For example, is given by um, the functions f of x equal to 2 over absolute value of x plus 1 minus 2, right? So for the rational function, you need to go into the denominator is not equal to 0, which p of x over q of x. So we need to find the domain of that by setting q of x is not equal to 0. So when the denominator is equal to 0, so the function will not be defined. So denominator cannot be 0. All right, so this is all we have to do, right? So we need to set up the bottom different from 0. So x plus 1 in absolute value minus 2 cannot be 0. Okay. So the way that we solve for the not equal to 0 and equal to 0 pretty much the same thing, except that we have to change the sign from like equal to not equal. So for this problem, we just simply add 2 both sides. So now the term just turns out to be in terms of the absolute values. It's not equal to 2. Okay, so, well, I mean, in terms of solving not equal to equation and equal equation, so it's basically the same thing except that we're going to change the sign from not equal to from equal to not equal to. And then when it comes to the absolute value, you're gonna set up like you got two conditions, like so one's gonna be positive and one's gonna be negative. So you're gonna get x plus one is not equal to two. And so both of them and x plus one is not equal to negative two. So this condition is very important. I just want to guarantee that the denominator cannot be like zero, meaning that the whole x plus one in absolute value cannot be equal to two. So you know the fact that when you have a negative number, we take the absolute value, still be positive. So that means that x plus one cannot be like a positive number, and x plus one cannot be a negative two numbers. In this situation, we just simply minus one both sides. And then we're gonna get x is not equal to one. So we do the same thing for the other side. So we're gonna minus one both sides. And then we're gonna have x is not equal to three, negative three. So as long as you can just simply write me the answer like that, I give you full credit for it. So the domain of function generally on the exam, we really want to make sure that people just simply, like just put it down in terms of x not equal to one and x not equal to negative three. If you are very concerned about the interval notation, like I said, I don't take away points if you forgot it, because this is the way that I grade the exam, so you don't have to worry about the interval notation. But if you really want to write them down in terms of the notations, for example, so this is optional. You just simply write. So we just basically do not include the endpoints of 1 and negative 3. So for the interval notation, all we have to do is just simply take from negative infinity. We just have to repeat negative 3 twice and 1 twice. So this is how we're gonna write on the interval notation. So you're gonna just have to repeat negative 3 and 1, and then just have to repeat 1 again using the union notation. So that being said, well, we're going to count any point between negative infinity up to negative 3, but we just don't count the endpoint. We do the same thing. We're going to count any point between negative 3 and 1, but just we don't count the endpoint of negative 3 and 1. So that's how we have to break it down in terms of the interval notation. We just have to repeat 1 and negative 3 twice and separate them in the interval notations. And that's what it is. However, on the exam, you don't have to do too much. Just simply solve instead of the absolute value is not equal to zero. I'm sorry, set up the bottom is not equal to zero. And make sure that we're not going to break the absolute values, because if you break it immediately, it's not going to give you the same answers. So you're going to have to make sure you're going to simplify uh, whatever the constant that we have, and then you're going to set up not equal to 2, not equal to negative 2. Any question? Any question? Okay. Just let me know if you have any questions, because like I said, this is the exam review. It's very important. I want to make sure that every single person can solve this question on the exam. Are we good? Okay, so please give me some response if you can, help me a little while. I just want to make sure that I can move forward, for those questions. All right, got you. Thank you. Um, all right, just let me know if I'm going too fast because sometimes when I just solve the question a little bit more quickly than it should be. So just let me know. So whenever you see like a rational function like that on the exam, make sure the bottom is not equal to zero. And before we break the absolute value, you have to set up like absolute value of A not equal to B, right? If you break the absolute values immediately, just like that, so you're not going to get the correct answers. You have to move the constant to the right before we break the absolute value. I am I am the type of person like love to repeat myself, so that I don't have to go over like 1,000 questions, something like that. Like make sure that you guys get it before I can move on. Okay, so far so good. And then now we have to sketch the piecewise functions, right? So it's it's important that we understand how the function looks like before we sketch it, right? So what the domain of that function, okay, and how the function looks like, and what are the endpoints. So once you can figure this out, you can just basically sketch any function. So I will show you how to do that, and then I can show you a curve on decimal so you can know like for which part. So so you remember that the questions on the exam also give you two lines. I'm not going to give you any uh parabola, whatever it is, right? And then you should know how it looks like. So this one have a positive slope. So how do you know is y equal to mx plus b? So the m was positive. So the line should go up for the first graph, right? And then another line, we got negative x. So negative x means it has a negative slope. So the line should be going down this way. Now, the next thing we have to know will be the domain of each function. The first one, we need to sketch the line y equal to x plus 1. So remember that each function will have different domain and they will never intersect. They will never have they will never have the x repeat with two different y values. So it must pass the vertical line test. If you see some line which is surpassing the other functions, you basically make mistakes on it. So the first thing we have to do, we need to sketch the line y equal to x plus 1 for x between -2 and 3. So remember that we do not count the endpoints for x equal to -2 and x equal to 3. So meaning that those 2 points will be the open circle. And the easiest way they can do, just figure out the endpoint for this kind of question. It's always easy to plug that in. So the reason why we need to compute the endpoint, just making sure that, well, we're not going to go too far away from -2 and not going to go above 3 or something like that. So I want to make sure the endpoint will be giving us like uh, how the curve going to get restricted on that domain. So the endpoint that we have was x equal to -2, x equal to 3 by looking at the domain of the piecewise function. So in this situation, that we can also find f of -2. So this one have to be the open circle because we don't have the equal sign. So for x equal to -2, we just have to plug that into a line. So that'll be -2 plus 1. So we got -1. And then we also have f of 3, and you just have to plug into the function as well, which is 3 plus 1, and that is equal to 4. So, and then we're going to utilize this kind of information to to plot into the function. All right, so let me just do for the first function, and then you will basically know exactly what I meant. So the endpoint that we will start from -2, when x equal to -2, the y equal to -1. And then when x equal to 3, the y equal to 4. So remember that we should have to open circle. Yeah, that's the exam from the student. I'm so sorry, my kid just like bothering me a little bit. Go sleep with mommy upstairs. Go. All right, guys. So this is how we're gonna figure it out. How we're gonna plug in the point. So now we're gonna go for the line as well. Sketch the line y equal to -x for x is greater than 3, for example. So for this particular curve that we do not count, we do count the endpoints, right? So we count the endpoints. Why do we have to count it? Because we have the equal sign. So we have to count it. So this one we do not count the endpoint. All right, so for the endpoint that we have just x equal to 3, and we just have to plug that in for the function f of 3 equal to, just plug into the function, we got -3, and try another one, x equal to 4, which we only pick the points. We only need 2 point to solidify the line. So we just pick another point, x equal to 4. So we have f of 4 equal to -4. All right, so when x equal to 3 and x equal to -3, so that's one of it, right? And this one have to be a like closed circle, right? This is open circle, we do not count the endpoints. And when x equal to 4 and y equal to -4 in this case, we don't necessarily need that, but we just want to make sure how the line was heading down into that direction. And remember that the second line will keep on going forever, going down forever, because we just have to like consider x is greater or equal to 3. So that can be 4, 5, 6, 7, 8, 9, 10, something like that. But the first function, we just have to count the x from -2 to 3. This is how we're going to have some restriction on it. Are we good? So now let me just use the decimal graphing calculators and see how it looks like. So first I want to graph the curve x equal to 1 for x was bounded between -2 and 3. Okay. So we do not count the endpoint when x equal to -2, y equal to -1. So we just make sure that this has to be an open circle. And Then the same thing when x equal to 3, y equal to 4, and this one also be the open circle. On the other hand, you're going to have the functions y equal to negative x when x was greater than 3. Yeah, so this like will keep on going forever, so you don't have to worry about like the bottom. So, but we do have the first point that we have to count was when x equal to 3 and y equal to negative 3. So that's very important. Are we good? Any question? Is that good, people? Any part of the question that you don't understand, just let me know before I move forward. But this question going to be 10 points on the exams. So I want to make sure that people know why we have some restriction because based on the domain of this, okay? However, if it asks you guys to find the domain of this particular function, what should we do? How can we find the domain of this function? The domain was based on the condition, domain, the domain for this function, for example, it should be from -2 to positive infinity. Okay, so that's the domain of the function. Just in case I'm going to ask you this, we just have to combine the domain on the tops for the first function and domain of a second function. All right, guys. So that's pretty much what we have for the piecewise function. Are we good? So remember that we should know how the curve looks like. There will be two lines on the exam, whether it's heading up or heading down. Is there any restriction on it? Is it bounded between the two endpoints? Do we have to consider equal signs? Do we have an equal sign? If we do have an equal sign, that means that we have to count the endpoint. If it doesn't have an equal sign between -2 and 3, meaning that we just have to exclude those two endpoints. All right. So far so good. Let's go to another question. So we need to find the average rate of change of the function of x equal to 10x squared plus 3x from x equal to 1, x equal to 2. So we need to figure out the average rate of change. It will be y2 minus y1 over x2 minus x1. So we need to find the y2 first. So we need to have the value f of 2 will be 10. I'm going to change the marker a little bit, just making sure that we do it properly. So the 2 square plus 3 times 2. So for this particular question that we're going to have, so we just have to compute it. So it'll be 4 times 10, 40 plus 6, 46. And then we can also evaluate f of 1. So we're going to take 10 of 1 square plus 3 times 1. So in this case, we're going to get like 13. 10 times 1 was 10 plus 3 was 13. And then all we have to do is just add it to the average rate of change. We're going to take 46 minus 13 over 2 minus 1. So that's going to give me the answer equal to 33. So 33 over 1 is 33. Okay, so as simple as that. So make sure when you solve this question, you're gonna plug in like two outputs, and then we're gonna subtract them and divide it by x2 minus x1. You need to know which one is gonna be the y2, which one is gonna be the y1. When you plug that in, you have to be extremely careful. The same thing that happened into question number 5, you can also solve for the m equal to the slope. The slope m can be found by taking y2 minus y1 over x2 minus x1. So the y2 that we got was y2 was 5 minus y1 was -4 over x2 was -3 minus 2 just simply -5. So that'd be 9 over -5. So 5 minus -4, just 5 plus 4 over -5. So we're gonna get negative now with 5. So you can solve for the equation which is y minus y1 equal to m times x minus x1. So we just use the point. You can use any point you want to. It doesn't matter which one. You can use the point x equal to 2, y equal to -4. Just have to plug that in. Y minus y1. So that'll be y minus -4 equal to the m was -9.5. X minus x1 is x minus 2, right? And then you might simplify a little bit further, but just sort of you giving the answer like that. I don't take away a point if you don't simplify this. Maybe I just rewrite them with respect to y plus 4, but you don't have to solve the entire equation. Just leave it like that. So I will basically give you full credit for it. Okay. The something that happened to question number 6. Sorry. So we have to figure out the line that is perpendicular to 2x minus 3. So that one will be slightly harder. So if you see the word perpendiculars on the exams, meaning that you have to take a negative reciprocal. So the negative reciprocal, you can see the slope that we have is 2. So we have to flip the slope and change the side for that. So that'd be, so instead of like we got 2, you should have 1/2, right? So 2 over 1, just flip the slope equal to 1 over 2. And then we also have, so this one is positive. We're going to make it negative 1 over 2. And now we just have to use the points, right? So the point was 2 and 3, -2 and 3. So now all we have to do is just look for the equations. Y minus y1, which is y minus 3, equal to the slope is -1 over 2. And x minus x1, which is x minus -2 is x plus 2, right? So that's that's what it is. All right, so you can already check it on decimals, just making sure that it makes sense to us. So let's say for part A, we have 2.2 and -4. And then another point was 3 and -3 and 5. So we need to find a line that passes through these 2 points, so which is y plus 4. Just want to make sure we get it right. Equal to -5, -9/5, and x minus 2. So that makes sense because this is the line that passes through these 2 points. So now we can also look at another questions where we have the point 2 and -2 and 3. And then we have the line y equal to 2x minus 3. And then I need to find a line that's passed to the point and also in this and perpendicular to the line 2x minus 3 that we found was y minus 3 equal to -1/2. You have a high chance to see this question on the exam. So apparently the line that we have was passing through the point and also make 90-degree angle with the line 2x minus 3. All right. Any question? All right, so we're gonna find the inverse. We're gonna do the long division later. So we need to find inverse of function. So the step to find the inverse, just simply make sure you're gonna replace x and y. So step 2, solve for y. Step 3, replace y by f minus 1. So the first step that we have to do, make sure this one becomes, so this one, the y become x. And that one's will x become y. So now the first thing we have to do, we're going to multiply both sides by y plus 7. And then we got to cross out the terms. So now we're going to have to distribute that. So first thing we have to do is just have to get rid of the denominator by multiply both sides by y plus 7. And then after that, we have to distribute. Y times x is xy plus 7x equals to y. So the next thing we have to do, we're going to subtract y both sides. And then we subtract 7x as well. So the reason why we have to subtract y, making sure you can factor it. And then we can factor the y, going to get, and then the x is going to get canceled. So we're going to get xy minus y equals to -7x. Afterwards, we're going to factor out the y. Negative x minus 1 equal to negative 7x. And then we divide both sides by x minus 1. Finish. And then don't forget to rewrite the y with respect to f minus 1 of x. And that will be the entire thing, which is negative 7x over x minus 1. So that's the inverse function. So the easiest way we can figure it out why they are the inverse to put it on the decimal calculator. For example, we can have the function y equal to um, on the exam that you don't necessarily have to do it, like put it on a graph. I just want to let you know. So when you plug that in, so you're gonna get f of x equal to x over x plus 7. So this is how the function looks like. And then when you look at the inverse, will be negative 7x over x minus 1. So apparently that they are parallel. I'm sorry, they're symmetrical about a line y equal to x because we have to replace them. So that's pretty obvious that we have these characteristics. Okay. Any question? Remember that on the exam you don't have to sketch the function, just simply like solve for the inverse function. That's it. The reason why I'm sketching, just making sure that we notice that those two functions must be symmetrical about the y equal to x. So this is how we can visualize. But in terms of the solving a problem on the exam, just simply swap x and y and solve for y and replace y by f minus 1. All right. The next thing we have to do will be the FOG. This is the question that I also graded on the homework assignments. Okay, so we need to simplify them. Let's say I want to find FOG of x and G of f of x. The question says FOG, right? So we need to know which one going to be the outer function and which one going to be the inner function. So the outer function that we have is here. So this is the outer function. And this is the inner function. So I just simply changing the color for that, just making sure it looks nice. And that one's the inner function. So remember that we always have to write the inner function first and see how it looks like. So the outer function will be f. So the inner function was 2 over x, right? 2 over x. So now, very important thing that we should know is that we need to replace the inner functions into every single x that we have for the outer function. So for the outer function that we had was, like x plus 1 over x plus 4. So I should put in parentheses x plus 1 over x plus 4. And then I have to replace it um, by 2 over x, by the inner function. All right, guys. So some of you might ask, like, how we can simplify them. I can show you a little trick for that. We just simply multiply the top and bottom by x over x. So now we just have to distribute that. So when we multiply by x over x, it doesn't change the value of the fraction. So we just simply do this times this and this times this. So 2 over x times x was just 2, and x times 1 just x, so 2 plus x over 2 over x plus times x is just 2, and 4 times x just 4x. Okay. So I just want to remind you that the domain of the composite function f of g of x so this function also depends on the uh I'm sorry. This function also depends on like 3 domains on the domain of itself of f of x and g of x. Okay. So in other words, when you look at the domain for f of x, so we have the set of x plus 4 is not equal to 0. And x cannot be 0 because the g of x, the bottom cannot be equal to 0. And we should have 2 plus 4x cannot be 0. So now when we solve all three, so we should conclude that x is not equal to -4, and x is not equal to 0. And x is not equal to and x is not equal to -1/2. So we solve for that. We just subtract 2 both sides and divide both sides by 4. So x cannot be -1/2. Okay, so we need to make sure we're going to combine all of the 3 domains. So that's the domain for f of g of x. So make sure that f of x have to be perfectly defined. You have to define some restrictions on the domain. And g of x, we have to define the domain for g of x. And then you have to define the domain of that, which is make sure the bottom cannot be 0. All right, so that's what it is. And let's move on to the next part. We need to solve the quadratic functions in the vertex form, something like that.
So the first thing we have to do is just simply know the fact that the standard form for the quadratic functions for the parabola should be something like f of x equal to a times x minus x squared plus k, okay? Where x and k is we call the vertex. So now we just simply solve for the vertex h equal to h, the vertex h. So we have to solve for x equal to negative b over 2a. And then we just simply plug in. So it's always better to rewrite a, b, and c so we don't make mistakes on it. The a equal to 3, the b equal to negative 12, and c equal to 1. So we have to plug in those indexes. So negative 12 over 2 times 3 was 6. Okay. So that gonna give us 12 over 6 was 2. And then we can find a vertex with k. F of 2 equal to, you have to plug that in. So you got 3x squared minus 12 times 2 plus 1. So all we have to do is just plug in x equal to 2 to get the vertex for y, which is k. And then we're going to compute this. We're going to get 4 times 12 plus 4 times 3, 12 minus 24, negative 12 plus 1, negative 11. So we can also rewrite the vertex in terms of, so the standard form, so that would be y equal to f of x equal to a will be 3 times x minus 2. So make sure you're going to chain inside for that. Square, don't forget the square plus k will be minus 11. So if you plug that in, or we can also expand it, like expand this, you're definitely going to get that one. So we have y equal to 3x squared minus 12x plus 1. And then we look at the vertex. The vertex that we got was 2 and negative 11. So that makes sense, right? However, if you rewrite the function, which is y equal to 3 times x minus 2 square minus 11. So you're definitely going to get the same thing. So it doesn't really change anything. They are technically the same function. All right, guys. So as simple as that. Now let's move up to the next question. All right. Let's look at question number 20. So a rectangular plot of land is to be enclosed by fencing. One side along the river, so it doesn't need any fence. Okay, so now by the dimension of the plot, you have the maximum area. So apparently they were going to set up like this is X and this is Y. So we need to build up this fence for three sides. Apparently that we have the total fencing that we have was the uh, perimeter of that rectangle. So we're gonna have the P perimeter equal to 2x plus y. So we don't count the other side length, so that'll be 2x plus y equal to 600. So now based on that, we can also solve for y. We subtract 2x both sides. So we're gonna get y equal to 600 minus 2x, or negative 2x plus 600, which is perfectly fine. And then now we're gonna plug that in, right? So the area always be the same, will be x times y, okay? And then remember that we have to replace the y by 600 minus 2x. This is what we just found earlier. So 600 minus 2x. So now we're going to rewrite the equation as 600x minus 2x squared. So remember that we need to identify A, B, and C's correctly. In this case, it was A equal to negative 2 and B equal to 600. So just making sure that the A was the term that go with x squared and B the term that go with x. Even if I wrote like 600x first, but the A still be negative 2. So all we have to do is just use the vertex formulas for this. So we x equal to negative b over 2, 8. So that would be negative 600 over 2 times negative 2. So we're going to get 600 over 4. So that's 150. Negative and negative, they cancel each other out. After we get the x, we can also plug that in to solve for y in this case. So we can have the y equal to 600 minus 2 times 150. So that essentially going to give us y equal to 300. Okay, so apparently the maximum error that we can have was the maximum errors, it should be 150 times 300. So that's going to give us 45, I'm sorry, 45,000. Are we good? Any question? Any concern? Any question? All right, so if there's no question, let's move on to the other part of the questions. Um, I think we did most of the question like that. And let's do question number 14. Okay, so we need to determine a maximum possible root. In this case, had to be 4 because the degree equal to 4, so the degree was 4. So it's based on the highest power that we have for the terms. The A was positive. I just want to even. And then the a equal to negative 2, a is positive, 2 is positive. And then the maximum number of turning points is 3. It's based on the root minus 1. So there'll be maximum turning points. And then we also need to find the end behavior. So the end behavior is based on the 8, right? Based on the 8, and then whether the root was even. I'm sorry, the degree was even or odd. So remember when a was positive, so we have to go up, right? So this one a was positive. And then it's also going up into the other direction because the even. So even degree, meaning that it's going to go, so the curve going to go in the same directions, right? The end behavior. When we have the odd degree, for example, the curve going to goes in like the opposite direction. Okay, so this is what we have. Any question, any concern? So they have degree 4, so they must go in the same direction. All right. Let me move on to the other questions. For example, we do question number 16. So for this particular question, we need to factor out the x to the third, and then we ended up with x squared plus 4x plus 4. So we can continue to factor this part. So this one we can factor like during the x method. So the sum was 4. The product is also 4. Two numbers satisfied for this was 2 and 2, right? So we can also rewrite f of x in terms of x to the third and x plus 2 times x plus 2, which is x plus 2 squared. So we need to tell us about the multiplicity, so we can solve each of them equal to 0. So the zero that we have, we're going to get x equal to 0. So now we look at the power for each term. So the power is 3, so multiplicity equal to 3. So something for that, we can solve for another 0, which is x-intercepts. So the x plus 2 equal to 0. Therefore, we have x equal to negative 2. And in this case, the multiplicity equal to 2. Okay, so the best way that make sure on the exam you're able to factor the terms and tell me like what multiplicity based on the power of the function. So the power that we have was 3 and 2. So that's going to give us the multiplicity of that. And so when m equal to 3, the function's going to reflect when m equal to 2, the function is gonna bounce, right? So if you want to see how it looks like for the function, you have to discuss that. So we just have those point, which is 2, x equal to -2, x equal to 0. So the function so it's going to go up and going down to that direction because of the m behavior. So this is how it looks like. Okay. And then it's going to touching the point -2 and it's going to bounce immediately. And then and then now you're going to reflect a little bit. Like I said, when we have like an odd degree, it's going to reflect a pass through it. When I have an even degree, it's going to bounce. So we can always check it on decimal and see how the curve looks like, which is x to the 5th plus 4x to the 4 plus 3x squared plus 4x squared. Oh, I'm so sorry. It was the 4x cubed. I'm so sorry. So you can see that the function is gonna bounce when it reaches -2, and it's gonna reflect when it go to 0. Okay. All right, guys. So this is what we have so far. Any question? Any concern? All right. So let's do the other questions. Let's do 17 and 18, and then we're gonna go back to the we're gonna go to the long division, and that's pretty much it. So now we have to like find a function degree 5, double 0 as x equal to 1. So we're going to rewrite the equation x minus 1 in terms of the factor. So square mean double 0 like with plus equal to 2. And then the triple 0 x equal to 3. So we're going to rewrite the terms. In this case was x minus 3 squared, x minus 3 to the cubed. So that raised to the third power was triple 0. Okay, so we're going to rewrite the equation f of x equal to 8 times x minus 1 square times x minus 3 to the q power. Now we have to solve for 8, right? We have to find 8. So in order to find the 8, we need to make sure that, well, you know what? It has to pass to the point 2 and 15. So plug in x equal to 2 and y equal to 15. So what we had was like, well, y equal to 15, and then 8 is right here. And then we plug in x equal to 2. And then we just have to do a 15 equal to 8 times, so this is 2 minus 1 is 1, times square is 1, times 2 minus 3 negative 1s. This q is just negative 1. So we're going to have 15 equal to negative 8. So therefore we divide both sides by negative 1. You got 8 equal to negative 15. And then finally, that we just have to rewrite the functions. F of x equal to, if you don't rewrite them, I don't take away points, just making sure we get this right. F of x equal to negative 15. And then we're going to get x minus 1 square. Because we have double 0, multiplicity equal to 2, and x minus 3 cube. Okay, just what we have. Any question, any concern? All right, guys. So now we're going to move to question number 18. Um, so we need to look for the vertical asymptotes, which is we're going to set up x squared, the bottom equal to 0, minus 4 equal to 0. Just set the bottom equal to 0. All right. And then we're going to solve for x. And then can factor the x is x minus 2, x plus 2 equal to 0. So in this case, you're going to get x equal to 2 and x equal to negative 2. For the horizontal asymptotes, we need to compare the degree, right, of the numerator and denominator terms, the functions. When we look at that, the degree was, so the degree was 2 on the top, was 2, and then the bottom degree also 2. So they have the same degree on the exam, making sure that we're going to write. And then we're going to take the the horizontal asymptote, which is the top coefficient over the bottom coefficients. So we look at a coefficient. We look at a coefficient x squared, just 1. So the 1 over 1, just 1. All right. We need to figure out the if there are any holes in the graph. The answer yes. We have a hole for this. So for the y-intercepts, just set x equal to 0, right? And then just have to find f of 0. So when you want to find f of 0, just ignore all the 0 terms over here. So this one going to be 0, this one going to be 0, this one going to be 0. So you're going to get just negative a over 4, which is negative 2. Two, negative 4. And then we can also look for the x-intercepts. So we can just have the set the top equal to 0, x squared plus 2x minus a equal to 0. So we're going to have this one going to be factored in terms of x minus x plus 4. x minus 2 to 0. So in this case, we can have x equal to -4 and x equal to 2. So now we observe, yeah, this is very important. We observe that the top and the bottom observe like x equal to 2 also appear on the denominators, right? Okay, so that means that, so we look at this. So, so if they have to repeat, meaning that there's a hole between them, that there's a hole. Okay, because we can always cancel out the top and the bottom by x equal to 2, so we have to omit this. Omit the x-intercept, and this one also be omitted. All right, in the graph. So we can technically figure it out by sketching a curve. So we have the function, which is y equal to x squared plus 2x minus 1 minus 8 over x squared minus 4. So apparently that the one-to-set was 2 and 0. I'm sorry, was 1-to-set 0 and 2. And the x-intercept was x equal to -4, 0. That's the only point that we have. And then we also have a little hole like x equal to 2. Okay. And then we also have the vertical asymptote, which is x equal to -2. And then we also have the horizontal asymptote, which is y equal to 1. So by looking at those two lines, you can literally see that there's a little hole between them. This is basically how we cancel out the top and the bottom. So there's a hole on the graph. And so this is how it looks like, but you don't have to sketch it on the exam. Just simply tell me what it is, how we're going to find the vertical asymptotes, horizontal asymptotes, and then x and y intercepts. You don't have to graph the function, just simply tell me what it is. So when we factor out the x-intercepts, and then you start off thinking that they have the same value as the vertical asymptotes, meaning that there's a hole, right? All right, guys, so what we have so far was simply the things over here, and then we just have to go to the last question. Use long division to determine the quotient and the remainder. I'll let you go after this question for sure. So we do question number 8. All right, so first you're gonna rewrite the dividend that we have. So we have to do like 3 steps because we look at the powers. The top power was 4, and then the power for the divisor was 2. So 4 minus 2 is 2, plus 1 step is 3 steps. So we're gonna rewrite the term x to the 4. minus x3x cubed minus 2x plus 3. And then I want to divide it by x squared minus 2x plus 2. So like I said, the first thing we have to do is just simply I pick x to the 4 over x squared, right? So we also have the dividend, I'm sorry, the quotients. The first ones have to be x squared. Now we're going to multiply that to subtract them, right? You need to multiply this. So we got this one will be equal to x to the 4 minus 2x cubes. So if we don't have x squared, oh, we have to leave some space between them so we don't make any mistakes on it. I would suggest that we make some space between because we do not have x squared for the terms. And then now we're going to plus 2x squared. Then we have to distribute that. And then after that, we're going to subtract this. So the first term always be 0, so you don't have to worry about that. The second one, we have to take -3 plus and plus 2. So -3 plus 2x squared, we're going to get negative x squared. I'm sorry, negative x cubed. So -3x cubed plus 2x cubed would be negative x cubed. And then, so we're going to get 0x squared minus 2x squared to be negative 2x squared. And then we just basically play the same game. Now we're going to bring down negative 2x. So if you don't leave space over here, we might make a mistakes by adding up like negative 2x and 2x squared, which is not the like term. So we can't do that. So the next thing we have to do, like I said, they're going to take negative x cubes over x squared. So we got this one equal to negative x. And then we're going to play the same games over and over again. We're going to take negative x times x squared. So we're going to get this one equal to negative x cubes. Negative x times negative 2x. So we're going to get 2x squared. Negative x times negative x times negative 2. Since time positive 2 will be negative 2x. So we're going to get the term, this one equal to 0. So we have to subtract this, right? And then we have negative 2x squared minus 2x squared, going to get negative 4x squared. Negative 2x plus 2x is 0, right? And then just plus 3. And then the last step that we have to do is just take negative 4x squared over x squared. So we got this one equal to -4. And then we just play the same game. So -4 times 4 times x squared with -4x squared. So since we don't have any x, -4x, -4 times +2x would be plus ax. -4 minus times 2 would be -8. And then I'm going to subtract this. So the whole term going to be 0. And then, so we're going to get 0x plus ax with -ax. 3 minus -a, which is 3 plus a would be plus 11. In other words, the division that we have was, it's going to have the quotients equal to x squared minus x minus 4. And the remainders have to go with the divisor. So that would be -ax plus 11 over x squared minus 2x plus 2. Okay, so that's pretty much what we have. Any question, any concern?
All right, guys. So if there's no concern, I will see you on Wednesday. All right. So before we leave, I would like to take attendance, and I'm gonna post all these notes on Brightspace plus the video, so you can also watch it again if you have any questions. Don't forget to send me an email for that. The long division is a very important question. You're gonna get 10 points for this questions. All right, guys. So let me take attendance. So that'll be 2/23. Sorry. All right, guys. So I will see you guys on Wednesday. Make sure you're gonna study all of these notes. Those are very important. Okay. All right, guys. So have a wonderful day. Stay warm, stay safe. I'll see you guys on Wednesday for the test. Take care. You too. Have a nice day.